All right, this video is for the lesson 2.7 homework, inverse functions. All right, number one.
The notation f to the negative first power means the blank of the function f.
Wait, f to the negative 1 of x, what?
The notation of f to the negative first power
Mm-hmm.
means the blank of the function f.
Means the inverse. Inverse of the original function f of x. Okay. Number two.
If the function g is the inverse of the function f, then f g of x equals blank, and f g f of x equals blank.
Wait, so g is inverse of f?
Yes.
And then it says g f of x? G f of x, like that?
And then f g of x.
What are your choices?
It's an X or Y.
Just get it.
Oh, you just get,
It's X or Y.
it's x or y?
The answer is X and X.
Should be.
X and x?
That's what it should be.
Equals f, and then f g of x equals x. Okay. Number three.
A function f has an inverse that is a function if there is no blank line that intersects the graph of f at more than one point.
It's a vertical line.
So they both equal x.
Yeah.
Yes. And it says such a function is called a blank function.
One or inverse.
It's a what?
1 to 1 or inverse.
1 to 1. So, no?
It's horizontal. It's supposed to be horizontal.
Oh, shoot. I'm thinking function test. So, if you take a function like a quadratic, right? And you draw a horizontal line on it, and it touches in two places, it means the inverse is not going to be a function. So what happens here, like if we do the inverse of a quadratic, the inverse would look like this. It would not be a function because the vertical line test would disprove it as a function. But if you have like a linear function and you do the horizontal line test, it only touches it in one place. So a linear function would be a one-to-one function. The original function and the inverse are both functions. So the original can be a function and the inverse not. Vice versa too. All right, number four.
The graph of f, the negative first, is a reflection of the graph of x about the line whose equation is blank.
I want to say that it's reflected across y equals x. Give me a second, let me look. Which means on a graph, yeah, like that's y equals x. Your function would reflect across that line. You could fold the graph on that line, and that's where your new function would be. All right, number five.
Find f of g of x and g of f of x and determine whether the pair of functions f and g are inverses of each other. And it says f of x equals 3x and g of x equals x over 3.
Okay, so if we do f of g of x, f of g of x would be f of x over 3, which means where this x is, we would put this in. We would plug this in. 3 times x over 3 is going to equal an x. So this one works, and then you check the g of x. So g of f, so this x would become the f function, and that would simplify to an x as well. which means yes, these are inverses. Old school way of determining if something is an inverse or finding the inverse. So like, I'm going to take this one, 3x. We turn it into y equals 3x, and then we'd switch the x and the y, and then we'd solve for y. Divided by 3, divided by 3, x over 3 equals y. So that would be the inverse of this. That's how you find an inverse. I'm sure we'll do that on one of these. Proving you can do this, but you can also just find the inverse. But since she's wanting you guys to show work, make sure that you guys know how to do the proofs on this. All right. 6.
It's the same thing. F of x equals 5x minus 7.
Okay.
G of x equals x plus 5 over 7.
Okay.
I can already tell they're not.
So f of g of x, but again, you got to be able to show your work, would be 5, and then this would be the x plus 5 over 7 minus 7. So what happens here, in the other one, this and this canceled. That's not going to happen here. So automatically, they're not inverses, just right off the bat, because there's no way we can simplify this down to an x. Okay? If we do the opposite, so this would simplify down to 5x plus 5 over 7 minus 7. Doesn't simplify to an x. G of f of x would be, so this x up here would be 5x minus 7 plus 5 over 7. Again, it's not going to simplify. The most this simplifies down to is that. So not inverses. That's all it's asking, right? Inverse or not an inverse?
It
Wait,
says
it-
it's incorrect. The first part.
What's the first part ask for?
What the f of x
F of G of x is.
Oh, it doesn't want it like this? All right, give me a second. So if we want to simplify, so if we need to simplify this one further, I would do 5x plus 25 over 7. This I would make 49 over 7, so I have a common denominator. And so now I have 5x plus 25 minus 49. It's all over one denominator. 25 minus 49 would give me the negative 24. So try, that's as simple as that one gets.
What'd you make it 49 over 7?
So I had a common denominator. You can't add or subtract fractions unless you have a common denominator.
Why 49?
Because 7 over 1, I need a common denominator. So multiply by 7 over 7
Okay.
to keep it in ratio. All right. Number 7.
So same thing. It's f of x equals 5 square roots of x minus 7.
5 square root x minus 7.
Yeah.
Okay.
And then g of x equals x to the 5th plus 7.
What was it, the third root of, or whatever it is?
A cube root?
Like cube root
Oh, is it
or a fifth?
is it written like this?
Yes.
Okay. Yep, that makes a difference. All that means is x minus 7 to the 5th. To me, my eyeballs see it better written this way. Okay? So if I do f of g of x, that x is going to become this. So now I'm going to have x to the 5th plus 7 minus 7 to the 1/5. Okay? Combine the like terms. So now I'm going to have x to the 5th to the 1/5. Power to a power rule. Power to a power. Multiply. 5 times a 5th is a 1. Gives me an x. So, as of right now, we've got inverses. Then we do the opposite. G of f of x. So this x, I'm going to make this. So I'm going to have x minus 7 to the 5th to the 1/5 to the 5th power plus 7. So again, this is going to cancel this and leave me with x minus 7 plus 7, combine like terms, equals x. Should have a function. Again, my eyeballs just don't catch the exponent rules, since that's not really written as an exponent, so I always write roots as a power. Ooh.
The function f of x equals x plus 16 is 1 to 1. Then part A, find an equation of f of negative 1 of x.
So find the inverse.
The inverse function. In part B, verify that your equation is correct by showing that f of the inverse of f of x equals x and the same thing.
So
Oh, never mind. It's the in. I'll just show you. Where's our part?
okay, let me see.
Inputting the inverse.
Verify that your equation is correct by showing that. Oh, okay, so just proving it, doing the proof. Okay. All right, so we would make the original function y equals x plus 16. Switch the x and the y. And then solve for y. So y equals x minus 16. That should be your inverse. F to the negative 1 of x should be x minus 16. The proof would be f of the inverse of f. This x would become this. So x minus 16 plus 16, like terms cancel, equals x. And then flipping it, the inverse of f of x would mean this x becomes this. Like terms cancel, equals x. Okay.
Function f of x equals 4x plus 5 is 1 to 1. Find the equation for f to the power negative 1, the inverse function. It says verify the equation correct by showing that f to the inverse of x.
Okay, just proving it.
Yes.
Okay. So we've got y equals 4x plus 5. Switch the x and the y. And then solve for y. So we would subtract 5 from both sides. and we'd have x minus 5 equals 4y. Divide both sides by 4, and we would have f to the negative 1 of x equals x minus 5 over 4. That would be your inverse. Does it want the proof equations, or what does it want on the proof? On part B? What?
So it says simplify your answer or whatever, and then it says f of the inverse of x, and then it says comma for all x greater than or equal to. For all x. This is what it was in the last one.
Because it's 1 to 1. I want to say x and x. Same thing, should be. Or no. Should be f.
So where are you?
Part B. What is it wanting?
Part B. So it's just the same thing except for immediately plugging it into the.
Oh, okay.
Yeah.
So this part is this. And then on the second one, it's the original function, right?
Yes. It's,
So here it would be this. Okay. Let me pause this. 'Cause that's just running. All right, 10.
Same thing. The function is x to the third power minus
X to the third power.
minus
Okay. So, does it say 1 to 1? Okay.
Function f of x equals x cubed minus 8 equals 1.
Okay. So the inverse, y equals x cubed minus 8, would be x equals y cubed minus 8. Add the 8 to both sides. So we would have x plus 8 equals y cubed. So we would cube root both sides. And so our inverse would be the cube root of x plus 8. So looking at those like on a graph, because that part where it's wanting the if x is less than and all that stuff. So if you look at the original functions, if it's not 1 to 1 is where that comes into play. This one is 1 to 1. So that's the original. And then the inverse is the blue one here. And that one is a function as well. We don't have to limit the domain. Sometimes you can limit the domain and make it a function. Force it to be a function by limiting the domain. But this one we don't have to do that with. But that's what all those other answer choices are.
so if it was x squared or like.
We can limit the domain of the original function. Okay. Number 11.
Does the graph represent a function that has an inverse?
Does the graph represent a function that has an inverse? Okay. Okay, so when you're looking at graphs, just so the video has this, if you're looking at a graph and it passes the horizontal line test, then it's going to have an inverse. And so I think the next one was something like this. That doesn't pass the horizontal line test, so it's not going to have an inverse. Okay, what number is that one that has that graph?
What?
What question number is that? Is it 13 or 14?
13. I think it's, or are you talking the one that asks for the inverse?
Yeah,
14.
14. Okay. So 14, your graph looks, let me look at it one more time. And I want you to give me those ordered pairs that it has here. Yep, so give me those two ordered pairs that you have there.
0, -1,
So 0, -1,
and then 2, -2.
2, 2, -2. So here's the original function. So remember that it reflects across, not that line. That's -x. Sorry.
So it reflects across y equals x, right?
Y equals x. It's going to reflect across like a line like this. All that does is it flips the x and the y values. So your new points are going to be -1, 0 and -2, 2. Your new graph should go through those 2 points. So just flip the x and the y. So x comma y turns into y comma x. That's a geometry thing, knowing that rule. Well, I just got done teaching that in geometry, how to reflect across that line. But all those little bits come back into play somewhere. All right. 15. This one only has 16 on it, right? Okay. 15.
Given the function f of x equals 7x minus 2,
Okay.
find inverse of f,
Okay.
and graph f and inverse of f in the same rectangular coordinate system.
So then graph them, right?
Yes.
Okay. So this one is going to be, let's see, x equals 7y minus 2, which would be x plus 2 equals 7y. Divide both sides by 7, f to the -1 of x equals x plus 2 over 7. Graphing this one, start at -2. And then you're going to go up 7 over 1. So 1, 0, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 7 over 1. So this point here is 0, -2. This one is 1, 1, 2, 3, 4, 5. So that's the original. Again, just flip the points. So 5, 1, 1, 2, 3, 4, 5. 5, 1 would be 1 point, and then -2, 0. That's always how I taught kids to graph these. So something like that. Just flip the points, especially if you know they're linear. If you start with linear, you're going to end with a linear. They're both going to be straight lines, even though my lines are not straight.
And use interval notation to give the domain and the range of f and inverse of f.
All real numbers, because they're both linears. Linears are all real numbers on both domain and range. All right, last one. 16.
F of x equals x cubed minus 12. Complete parts A through C. And then find the equation f to the -1 of
Okay.
In graph, it's the same as last one.
This one sucks, but we'll get through it. Okay, so y equals x cubed minus 12. So x equals y cubed minus 12. So x plus 12 equals y cubed, and then cube root both sides. Okay, so with one like this, when you graph it, x cubed minus 12, and then x plus 12 cubed. You want nice, pretty points. So this is the original one, the x cubed, that's called a cubic function. But if I make a table here, I can find nice, pretty numbers. So like -2 and -20, like this one right here is a good one. 2 and -4. 3 and 15. Those are easy ones to flip. So 2, -4, 3, 15. So these are ordered pairs for my original, which means for my inverse, it would be -4, 2 and 15, 3. I just try to find easy numbers to work with, not ginormous, not fractions, not anything like that. And then it wants domain and range on those.
Yeah, it's negative and
All real numbers on the domain and range for both of those as well, because you don't have a denominator to worry about. All of those other things that affect your x and y values aren't there on that one.